And now when we look at this next one, we notice, hey, the sample size has changed. So when I look for the mean and standard distribution, or excuse me, standard deviation, of course the mean doesn't change. It's still equal to mu, which means it's 25. But the standard deviation now has changed because I've messed with the sample size. So where before it was 7 over square root of 10, now it's 7 over square root of 100, which is 0.7. So notice it's gone down a lot. And again, don't forget that I need to write if the population is greater than or equal to 10n. And on this last one, again, as you read, make sure you start underlining things. So I see the distribution of the weights of jars is approximately normal. That's talking about the population. And then it has a mean of 16, still talking about the population, and a standard deviation of 0.15, still talking about the population. There's been no sampling yet. And then it asks me which one has a higher probability, more likely. Randomly selecting a single jar, so that would look like a probability that x is less than or equal to 16, versus randomly selecting 10 jars. So now this would be a distribution of sample means, and so I would be looking at the probability that the sample mean, the average, is less than or equal to 16. And of course what I know is, since this one comes from the population and this one comes from the sample means, that this bell is definitely going to be narrower. So remember, my X bar bell is narrower than the population bell. And we talked about this one in class today. Of course, if I have 16.1 in here and I draw 16 on it, versus the 6.1 in here and I draw the 16 on it, this one will actually be smaller because the tails will have pulled in. Remember, we looked at the difference between drawing the population bell, it would be even better if it was wider, versus this sample bell, and how the 16 doesn't move. So there was a lot more area over here, and then when the bell moved in, now more of it, it's up here at the top, right? It got higher peaked. So out here in the tail, we'll actually have a smaller area. And the other issue behind that is that averages and always have lower or are less, averages are less, let's put it that way, averages are less variable. I hope you can read that. Move my face up off of it. And the rest of the notes will be ready for you tomorrow. I'm going to look, so double check School Loop. I might actually assign you some problems to go with this since it ended up being shorter than I remembered.